Hi, welcome back. I was just finishing this question and starting question 10.7. So let's do it. It says at a baseball game, we have 42 out of 65. So kind of how we made a table like this, we probably want to do the same thing there. It says we're going to have to take, here we took suburban minus the city. Here, if I read forward a little bit, I got to take game minus concert. So we know that it'll make it easier on ourselves if we do list that one first in the concert. Okay. So it says 42 out of 65 were randomly selected at a baseball game, and at the concert, 34 out of 52. So I can kind of check conditions already. If I look at this, that means, just doing some quick math, 42 minus 65, that 23 said no, 42 said yes, and 23 said no. At the concert, $34 said yes, 18 said no. So remember, for our conditions to be met, we need at least 10 yeses or no from both groups, and I like that all of those numbers are greater than, or 10 or greater. So that's kind of cool. So if I look at this idea, R and I, it does say random, and the number is at least 10 successes and failures from both groups. I like it. And then we just want to make sure it's independent. Now, nothing in the question talks about conditions, but again, this is how you approach every question. These are the habits of mind. Okay. Now, to find the difference between the two groups, we need to subtract, and we get 8. So the researcher wants to test the claim that the proportion of iPod owners at the two different venues is something other than exactly the same. So what we'd have to do, even before we test our conditions, is do an H sub O. Well, the H sub O would be, you have to assume that they would be the same. The proportion at the game would have to equal the proportion at the concert. And if you believe it's something different than that, I don't see anything in the question that would lead me to believe that. It's something other than that. So a 90% confidence interval for the difference in the population was produced, and this is what we ended up getting. So the problem here is, notice the number 0 fell in there. So again, what the calculator is doing is taking the data you gave it and throwing out a confidence interval and saying that you're 95% confident that whatever the interval is, you're 95% confident that falls somewhere in here. So what they've done is they said, they're saying that the difference is somewhere between this number and that number. Notice how the number 0 falls within here. So what they've done is they're actually 95% confident the interval's in there and that one's in there, so that's a problem. As we look through here, because the confidence interval includes a 0, the researchers can prove that they're the same. That doesn't make sense. We actually have to assume they're the same, and we're trying to get proof that they're something other than the same. See how we were trying to figure out, are they different from each other? So if I read C, I recognize this has to be my answer. The researchers can't conclude that the proportion of the two venues is different. In fact, we have data that shows that 0 is within that interval, and that would mean that if I took the proportion at the game minus the proportion at the concert, I got exactly the same number. If you take two numbers that are the same and subtract from each other, you get 0. So, okay. Next question. they have an SRS size 100 taken from population A with 80% successes. So basically the same table. It's kind of cool, right? Using the same table almost exactly. So 100 from population A, and I am going to do A minus B, so it makes more sense to put A on top, and 80%. So that means 80 yeses and 20 nos. I've got at least 10 successes and 10 failures from sample 1. Population B, 50%. Okay. Oh, but I talked to 400 people, so that would be 200. It's definitely at least 10 successes and failures, okay? And it says they're independent, which I like. This letter SRS is short for simple random sample. So I have all my conditions met. Now it says the sampling distribution for the difference in A minus B in the sample portion has what mean and what standard deviation? Now, I'm not subtracting the raw value. Oh, I messed this up. Sorry about that. Oops. I need to find my proportion. It doesn't matter, but that would be correct, and I don't want you thinking about that wrong. The proportion here would be 0.65. The proportion at the concert would be 0.65. It's a slightly different decimal, but it's definitely 0.65. So notice how the difference in proportion was 0, even in your sample data. Interesting, right? So the reason why this one was different than this one is this one is a mean question, right? And this is a proportion question. So I did calculate the proportion of my sample, the difference, and it was 0. Interesting. Okay, back to here. So this is 80, and this is 0.5. And so the difference we get is 0.3. Notice all of them have that, so no problem there. So really the question is, what is the standard deviation? Okay, so back to our formula sheet. We've been using it a lot in chapter 10. I just keep going back. My sample proportion, when I use 2 samples, is going to look like this, right? So unless these are equal, and we know they're not. So we're not going to use this special case. We're going to use that first sample. Okay. So the first proportion was 0.8 times the complement over the number in my first sample. The proportion of my second group times the complement over the number. So they're asking you to calculate this by hand. This is actually pretty easy to do in the fancy calculator. And I typed it in exactly like it looks like on my little sticky note here, right? I get 0.47. That's answer C. Hopefully that's the one you came up with. Let me know if you need help calculating that. All right, last one. Such a cool question. How much more effective is exercise and drug treatment than just drug treatment alone at reducing heart attacks among men 65 or older? To find out, they performed a completely randomized experiment involving 1,000 healthy males in this age group. Half of the subjects were assigned drug treatment only, the other half assigned to exercise and drug treatment. The most appropriate inference method. So I see nothing in here about the standard deviation of the population. So we can't choose anything with Z, right? What have I done here? Hold on. Sorry, I'm sorry. It's late in the day. The most appropriate inference method for the original research, how much more effective is one treatment than the other? Okay, I've read this question multiple times. I thought I had the hang of it here. It seems as if, depending on how you read the question, if you think you're going to measure something like their blood pressure, you would pick an interval. The challenge here is, I guess, the only way to know what you're doing is whether you have a heart attack or not. So that's technically a yes or no question. So, yikes. Technically, as far as the way it says here, it is a yes or no, and I'd have to pick a 2 sample Z interval. Okay, we'll talk in class why you'll pick an interval over a proportion, but